Hello, today I want to talk about like fractions and like all the laws about it, blah blah, that type of stuff. Like what you need to know about fractions. So first of all, what is a fraction? Um, Basically, a fraction is like different, basically different percentages, parts of a whole number. Different percentage, but part full number. Okay, look. So I don't know how to quite explain it, but it's basically like parts of a whole. So what I mean by this is, so let's say this is how a fraction looks, right? Right? You have a number on the top and a number on the bottom and this division thing. And basically, this number is a numerator, term, and that is how much you have. How much. And this is a denominator, and that is like the total, like how much that is. And this is the division operation. So basically, I mean, they don't quite actually divide them. I mean, they do divide in like, calculators, but basically, I'm not sure how to explain it, but basically, yeah, that's what it is. So let's say an example of what I mean by this. So we have this type of shape, right? And I shade this, and I shade this one, and this one. And a question for you is like, what fraction of the shape is shaded? So you're like, well, 1, 2, 3. So what do I put 3? No. Or so you might think, okay, if it's not 3, then 1, 2, 3, and then 1, 2, 3 are not shaded, so it's 3 of the 3. No. You count how much in total there is. So 1, 2, 3, 4, 5, 6. So 6. And then we're asked how much is shaded. Then after we count the shaded parts, and that's 3. So the answer is 3. And you can also simplify that to, like, for example, how, like, what goes into a 6 and what goes into a 3. Well, both are like in 3. So divide both by 3. 1 over 2. And then that's equal to 50%. So it's kind of similar to percentages, but at the same time, not quite. Then after that, we're going to talk about reducing fractions. So and what I mean by that is making as small as possible, but same, like equal to. You will understand. It's basically like simplifying. So let's say I have 1 over 2, right? So no, I mean, look, do I have a shape here like that I would need? Okay, let's just, yeah, let's do this one. Yo, chill. So I want to make, yeah, are they same? Hopefully they are. So these two are, imagine they're exactly the same. Yeah, imagine they're just exactly the same. So over here and over here, right? Over here I shade this part, like the half, and over here I shade this too. I mean, it's gonna be easier if I do this. So look, these are two separate parts, right? I think I can do it. Wait, blue on blue. Oh, what? Why can I not do green? Oh, I can. I mean, green doesn't seem as good, but yeah. So from last time, we understand that the fraction here is 1 over 2, right? Because like there's two sections, and then only one section is shaded. And over here, there are 4 sections, 1, 2, 3, 4, and 2 is shaded, so 2 over 4, and we can simplify that, 1 over 2. So these two, they are equal. So let's say you have like 3 over 9. You can do 1 over 3. They are, like, the numbers are smaller, but they are equal, like, yeah. And the way you kind of need to know this is like basically by using like the greatest common factor, I guess, or most of the time smallest. So let's say great, well, I'm not really sure if that's the key. I mean, no, you actually do need a greatest common factor. Pardon me. Greatest common factor, GRC. And so let's say we have 36 over 48. You're like, okay, in both of these, there is a 2. But then if you do that, it's going to be, so that's going to be 15. This is so 18 over 24. You can still simplify again by 2. And that will be 9. And that will be 10, 12. And then you can simplify this by 3. That's going to be 3, and that's going to be 4. Now this is the like maximum. However, instead of doing all these steps, you can just think of what is the greatest factor. I talked about factors last video. Basically, factor is what like the number is created kind of from, like, not the true thing, but at the same time it is the true thing. So let's say factor is 36. So 1, 2, 3. So what actually creates it? 8, 9, 12, 18, and 36 itself. Then 49. 1, 2, 3, 6, 8, 12, 48. So basically you check out what's the biggest. Why the biggest? Because, like, instead of making all of this, why is it blue? Instead of making it, like, you know, doing it step by step, we could just do, for example, 12 is the biggest that they both have. So we can just divide them both by 12. So this would be 3 and this would be 4. And it would be the same. So it's just like, you know, small steps and like just easier. Another way for the same question is what's it called? Prime factorization. And what I mean by this is basically you do the tree thing, basically. Yeah, the tree. 36. Well, let's do 12 again and then 3. No, let's actually do it different. Let's do it with the 2 thing. 2 times 18, yep. And then 9 times 2, and then 3, 3. Now 48, 12, 4, 4, 3, 2, 2. After this, we bring all the numbers that we have over here. Wait, okay, so, so we have 18. We have a 2 times 2 times 3 times 3 times 9 times 12, and that's divided by 2 times 2 times 3 times 4 times 4 times 12. That should be it. Yeah. Over here, the 2, they what's it called? They get rid of each other. Over here, this gets rid of each other. After that, This doesn't add up to my calculations. Have I done it wrong? Um, hmm. I'm not sure why it's not working. First of all, the 18 doesn't cancel. And second of all, what if I do it like this? 3. Still doesn't cancel. Okay, that's a problem for me to think about, but most likely it's just, a glitch in the matrix, whatever it's called. Yeah. Because I don't understand why it doesn't work. I mean, in my example, I used a 12 for both of them, like 36, 2, and a 3. But okay, never mind. Now we're going to talk about multiplying. I mean, we talked about that already. Direct multiplication, cross. Okay, yeah, let's just multiplying fractions, and basically the rule, you should already know it. It is AB times CD, and that you just times these two. So, and yeah, that's the rule. So first of all, the first method is direct multiplication, and basically, let's say we have this, we just times them straight away, and then we just simplify them after. However, instead of doing that, we can do cross cancellation, or was it saying? Yeah, cancellation. So basically, so what I mean by this is, let's say we see these, right? Like, we can divide these numbers by, like, simplify them. So let's say what goes in the 6 and what goes in the 2. Well, both 2, so we can do this. And what we get at the end is the same result as what we got here. So it does work. After that, we have an example. So what do you do if you see this? Well, you just make it like this, and because it's a full number, so if you add the 1, it's the same. That will go to 40 over 60, and then 20 over 3. So in the same kind of way, you could have done this kind of thing where you can see that there's 2's in these, so 5 over 3 times 4 over 1 gives 20 over 3, same as here. So yep. Now let's talk about dividing them. So the rule is AB divided by CB equals AB times DC, and you like switch them places, flip. So it's basically like keep, change, as you can see we changed it, and then flip. So key change, flip. Kind of like KFC, but not KFC. And then you just times them, like the same way. This times you know. So, oops. I'm just thinking, how do I do this? So let's say we have 14 divided. Okay, no. So first of all, let's say we have oh my god, why is that ruler? 5 15s divided by 3 over 4, right? Straight away we just make it Okay, so look, we can do this thing. Like, you don't do it before times and you do it straight away if you see it. So we can have these numbers. So 5 over, like, how much 3 goes into 15? 5 divided by 1, because 3 is 1. 4, then you flip it. 5 times 4 over 1, add 20 over 5, which equals to 4. So yeah, and that's kind of it. That's the all example that you need, teachers. Yeah. So, and when you plus and minus, it's basically whatever it is, you have to have the denominators the same when you plus and minus, right? So let's say the rule for it is that whatever it is, that this thing has to be the same, and then you just add or minus these two. These are the same. So an example that, let's say you have 3 plus 4 over 3. The answer is going to be 6 over 3, and that's 2. But let's say you have 1 over 3. No, 1 over 1. No, 3 over 1 plus probably 2 over 4. You can times, you need them the same. So you don't divide it to make it a 1. You times this to make it a 1. Or 4, I mean. So this times 4, and since you're times in this one, you also have to times the whole fraction. So it turns into this times, plus 2 over 4, 16 over 4 equals to 4, by the way. After that, why is it not working? Oh. Now let's talk about, 1 second. Okay, now let's talk about mixed and improper. Oh my god, improper. Proper fractions. I don't want to write the whole word, this is fractions. Mixed and improper fractions. So a proper fraction is when like it's like this, right? And the a is smaller than the b. So for example, 2/3. Mixed. Oh no, improper I mean. Improper is when the a is over or equal to b. So let's say 3/3 or 4/3. That's improper. And mixed is basically when there's a c, a, b, and the c is like a whole. So basically a c is when there is a full number here. So let's say 4/3, you write 1, and then because like to get the 3, and since there's 1 left, you just do this. This is how it is, because there is a 3 inside and the maximum is 3. Oops, no, you should be saved. There's already a 3 inside, so yeah. But yeah, these two are equal. And then let's talk about how we get from mixed to improper. So this is the mixed. So what you do is basically you times these two, 15, and then you plus 2. So the answer is going to be 17/5. So these two and then plus this. So now the opposite, improper to mixed. I just don't want to write it down. So let's say you have 8/3. You just like basically you can do the regular division, right? So so how much 3s are now? 8. Well, it's going to be a decimal, but how much can you put in? 2, and then it's going to be something else, but you don't care, so you just put 2, and then how much is left? Like it was 6, so there's 2 left, 2, and then there's 3. So this is how you do it. Oh my god. Okay. Now let's talk about percent, because like basically it's about fraction, because a percent is basically like when you in a fraction, it could be, you can put it as a fraction, which like the denominator, so basically a denominator. So percent is when the fraction has a denominator of 100. So let's say 80% is equal to 80/100. So percent is out of 100. So let's say percentages to fractions. So let's say you have 80%. I mean, I kind of just showed you right here. So let's just take it as like this, and then you can like simplify, of course, what goes into these. Like what's the biggest one? Well, 20, so that's going to be 4/5. And then what's going to be fraction to percentages? Well, let's say you have 2/25. To make this a percent, you can make this 100, so times it by 4. Times it by 4 to make 100, and then you times this by 4, so that's 20, so that's 20%. So yep. And now let's talk about equations involving fractions. So let's say we have like something like this. So the way you do this is basically you have to get rid of the fraction, and the way you get rid of the fraction is basically you can times both of these by 8, so times this by 8 and times this by 8. Why 8? Because it's basically what's it called, like the biggest number. I'll show you. So look over here, it cancels out, so we have this like over take away 4. I mean, you would have a 1 here, but 1 doesn't change anything, so yeah, that's what it is. And then over here we have an 8, how much, like you do the division, so how much 4s on an 8, that's 2, so this, and then that's just 2x, and 2x is equal to this, and then you just do, what's it called, like, you know, rearranging, so you get the x here, so there's x1, and so x is equal minus 4. Another way to think, so let's say you have this, right? Again, times by 6 to get rid of this, and over here you have a 6, so that would be 3x equals x minus 1, so 2x equals minus 1, and then you divide by 2, so that equals x equals minus, so basically a half. So, and to make this a positive, you are able to, oh no, never mind, oh my glitch, yeah, never mind. So that's how you do it. I mean, you could put it as a percent, like take away 0.5. Fractions in exponent. So basically the rule is, so let's say you have a m n, that's equal to square root n a m. So this number is over here, this number is over here. So let's say we have something like 8 to the power of 1 over 3, and that is times by 2. First of all, we have to make this an actual, like, singular number, if that makes sense. And what this 1 over 3 means is, like, what numbers give 8 by the number. Basically, what number created 8 by times it only by itself? So 2 times 2 times 2 gives 8, so 2. And so we can just put 2, and because we like made it smaller, we used this 1 over 3. So 2 is just alone, and then it's squares, and then it's a 4 because 2 times 2 is 4. Now let's say we have something like this. So in this case, this is basically equal to this, 81, 1 over 4, like this, and then you open the brackets, and when you open the brackets it goes like this, 4, 81 over 1, 4, and the same thing, what numbers make 16 and what makes 8 by times it by itself? Well, look, this is 2 because 2 times 2 times 2, 2 to the power 4, basically. Oh my god. Basically it's 2, trust me. And then 81 is more harder. So we know that 9 times 9 gives us 81. So could we do maybe 3 times 3 times 3? Well, no. Because that's 27. So we have to think of a number that makes, like, the way we can think. So basically we could probably do hmm. I mean, let me ask ChatGPT if I'm honest. What number? Oh, it would be 3. Sorry, guys, because yeah, basically 3, not 3 times 3 times 3. It would be this, and this is equal to 81. So yeah, 3. I'm just yeah. So another example. So let's say you have 4. No, let's square root 4 x squared y squared. You do the thing that we just did to make the 4 positive, basically. So look, where we had this, so we did this, and then basically we just make these the fractions, because like I mean, no, actually, no, we could just do this. 3 over 4. And then from our laws, we know that we can just times these. So when you times them, because there's times here, you just add it. But so no, you times it. You usually do a plus when you times it, but in this case you just times it. So this is 3 over 4, so x 3 over 4. This is y 2 over 4, so y 1 over 2, same thing. Oh. Now let's talk about so let's say we have this type of thing, right? What this basically means is that how can I explain? Basically, then I'm gonna watch a video about it, and then yeah.